Okay, yeah, the tapping needs to stop so that we can focus on this. Now, we're about to learn number word problems. There's a huge array of word problems that you guys are going to get very, very good at. You're going to get very, guys, stop please, turn around. So you're going to get very good at these different types of word problems, and number word problems I like sort of in the beginning because it helps you to learn how to take words and turn them into an equation, right? That's the big key. So what we're going to do first, before I actually put a problem up here, is we're just going to practice putting words into an expression. There may not be an equal sign, right, in some of these. I'm just trying to get you used to something. So if I said one number, so this will be our first example, right? These are examples. If I said one number is 4 more than another. Whoops, another. Another. Why does that not look like another? Okay. One number is 4 more than another. Yes?
Would it be x? X is greater than 4?
So you have two, not quite. I see what you're saying, but no, that's not quite it. Basically what this is, it's one number is 4 more than another. Which one is the foundational number? Which one? Is it the one number or the another number?
One number.
One number is 4 more than the thing, like the main thing. The another is the main number, right? This is based on whatever this is, right? You see what I'm saying?
Yeah.
This number is dependent on this number. Does that make sense? Like this number is, once I know this, then I know this number. If I know this, I don't know this. You know what I'm saying? Well, I could figure it out. But this, I'm going to make the another number x. So whenever you see this, right above the word another, put an x. So you remember that's your first number. So my first number is x. My second number is what? One number is 4 more than another. So this number is, how would I write 4 more than this?
What?
Say it again.
X plus 4.
X plus 4. So there's my two numbers.
Plus 1 equals what?
One number is 4 more than another. Well, the another is my first number. My second number is the another plus 4. In other words, x plus 4. So immediately I got two numbers. Does that make sense? You get that?
Plus 4.
There's another way to do this. I could also do this with systems of equations. I probably should teach that too, but I'm not going to.
X equals 2?
No, we don't know. We don't know. It could be lots of things. If x were 2, this would be 6. If x were 3, this would be 7. If this were 100, this would be 140. There's no equal sign right here, right? Right? You can't solve for x because there's no equal sign. I'm just helping you to set up these problems. Okay, let's try another. Yes, question.
So is could the one number be y?
So this is the one number. You could also do this as a systems of equations. You could also say y, you could say y equals x plus 4. You could do that. Does that make sense?
Yeah.
So there's two ways to do this. I'll show you both ways. And you can do either way you want. This is one way where you have the two numbers in terms of x. You with me? You with me? Two numbers in terms of x. There's no y's at all in this method. So this is now method 1 because Noah, was that Noah? Who said that? Was that you, Noah? Or Abe? Who? I can't remember who asked about the systems and why. So this is all right. So this is the systems method, which means you have to have two equations, right? So that's the first equation, but I haven't given you the rest of the word problem. Now let's try another one. I'm just helping you learn how to set these up. So let's see. What if I said one number is 7 less than another. Okay? How would I set that up? Another is my x again if I use this method over here. So my first number is x. My second number is what? My first one number is 7 less than another. X minus 7. Right? Now, if we were using Aiden's method of using two different variables, was that your method? Or I thought it was Noah's. Oh, it was Noah's. I said that. And you said you. All right. So it was Noah's method, right? The systems of equation method. One number could be y, and this could be x. So we could say y is always means equals 7 less than another. So x minus 7. Now, some people would tend to do this. They would write 7 minus x. 7 less than another? Wrong. Because it's 7 less than. You can't have less than until you have something. So you got to put the something first. And then you say less 7. Does that make sense? You can't have a less 7 less than without a number first. So you got to put the x first. And then the minus the 7. Okay? So whenever you see less than or more than, it's always less than would be minus 7 off to the right, and then the thing that it's less than goes to the left. Right? Minus 7, and then the x goes into the left of it. All right, so that's how you set that up. So if we, okay, one last one. One number is 5 times another. Okay, one number is 5 times another. So I know my first number, if my another number is x, my first number is x, right? First number is x. My second number is what?
X times 5.
X minus 5?
X times 5.
That's a good question. What is it?
X times
It says
5.
one number is, how would you write 5 times a number? What would it be, Violet?
X times 5.
Oh, right. Or
Oh.
when you write in an algebra, you don't put the variable first, right?
Yeah.
You don't do x5, right? You do 5x, right? So it's going to, the second number is going to be 5x. x5 is technically true and correct, but
I'm kind of confused, but on just the whole topic, but I think I'll pick it up.
okay. So I think you'll pick it up as we move forward. But can you understand that if one number is 4 more than another, this one number is based on whatever this is. So we make this one x, right? And if this one is 4 more than the x, 4 more than is just saying x plus 4. So the first number would be x, the another. Second number would be 4 more than that, x plus 4. One number is 7 less than another. The another is the base number, right? That's the x. That's my first number. The second number is this, which is 7 less than that. So I write x minus 7, right? And then this one says 5 times another. It doesn't say less than or more than. It says 5 times. Times is multiply, right? So it would be 5 times x. Now, if I was going to do this one as a systems of equations, Noah, what would it be?
What?
How would you write this as a system? I mean, as an equation with two variables.
You just do 5x equals y? No.
One number is y. One number is y. This is y. So y,
Oh. Yeah, so y equals 5x.
there you go. That's it. Y equals 5x. Right? So I've never taught this where I'm teaching both methods at the same time.
It wouldn't be wrong, would it? If you did write x equals y times 5y?
No, that would actually be okay too. Because it doesn't matter which one you make x and y, right? Good question. Really good question. All right, so now that we've got that set up, let's do a problem. I'm running out of time. Nate, can you just ask them if I could have like 3 or 4 more minutes?
Just Jen coming in for English.
Oh, is nobody in there? Oh, it's just Jen coming in?
Jen will have to come in here for English, yeah.
Oh, okay, great.
But I can,
Oh, then that's fine. Don't worry about it. I'll just deal with it when she comes. All right. So here's a problem. We're going to do two different problems. Here's our first problem. One number is 3 less than another. 3 less than another. Their sum is 21. So write that down. One number is 3 less than another. Their sum is 21. Okay? So if I were going to set this up, I'm going to do it both ways. Okay? This is going to be, say, you know, only one, this will be the one variable way. And this will be the two variable way. So you can see both ways. And either way is fine with me, okay?
Oh, Gary, on
Yeah.
this page, should we do like part 2 or just keep it there? Like,
On what part? On what?
on the title. Should we just write that?
Word, number, word problems.
Like continuing or no?
Well, but this is the first time I've taught it.
Oh, okay.
But I don't know, so I don't think you need, however, you know, whatever works for you, whatever makes sense to you. Question, Weston?
actually, as the answer.
Oh, and then is that the answer you're calling?
Yeah, I was gonna say how you would write.
All right, so which one we're gonna do, this method or that method?
Then the two variable one. It would.
Two variable, okay, what would
I
you
think
get?
it would be x plus or minus x plus x minus 3 equals 21.
Oh, I see what you're doing. All right, so you're doing this method.
Oh, okay.
So you're saying, okay, so if we use this method with one variable, this one number is 3 less than another, we're going to make x another x. So the first number is x, the second number is 3 less than x, so x minus 3. Everybody understand that? Does that make sense? All right. Now, those are our two numbers. It says their sum is 21. How could I add these two together? What would I get if I added these two together?
X.
I'd have, how many x's are there?
2.
2 x's minus 3, that's their sum, is, what do I put for is? Equals 21. Now I just solve it. I'm going to add 3, I've got 2x is equal to 24, divide by 2, divide by 2, x is equal to 12. Is that what you're going to say, Weston? Is
Yep.
that what you're going to say, whoever else was?
It was Aiden.
Aiden? Oh, you got the answer. What did you get? Is that what you got?
Wait, what?
Did everybody get this? Do you understand what I'm doing?
Kinda, yes.
There's my first my first variable, or my first number, and my second number. It says their sum. Sum means I add them together. So I added them together. I have now 2 x's minus 3. And it says their sum is 21, equals 21. And then I just solve for x. And I got x equals 12. So the two numbers are, what? 12 and what? If x is 12, what's 12 minus 3 for the second number? You guys, wake up. What's 12 minus 3? 12 minus 3. So in 9. Yeah, okay.
Just a quick question.
Yes, quick
I'm
question.
confused on how I got 2x minus 3.
Because look, if you add x plus x, how many x's is that? 2 x's, right?
Got it, thank you.
Exactly, good question. Now if I was going to use the variable method, I would make this y. And I would, if I use the variable method, I actually do exactly every word as it says. It says, watch this, it says one number, that's y. And then it says is, what's that for? Equals. 3 less than another. So there's the another, I put that first, and then 3 less than, so minus 3. That's my first equation. And then it says their sum, the sum of x and y, is 21. So I could say x plus y is equal to 21,
Or
right?
can't it be, what's called, can't it be 21 equals x minus 3? Because you can make your 21y.
Say it again. Can you say what did you say again?
Can't you make your 21y for the sum? So instead of y equals x minus 3, it's 21 equals.
No, I don't think you can. One number, your one number is x, the other one's y. You can't make the answer y. You can't make the total y.
Then we'll make up the variable way. We could have a bunch of different answers.
What? Go this way?
There's more than one answer.
Well, no. This is where now I'd use systems of equations, right? Right? And I'd do substitute. So I would substitute this in for y. So I have x plus x minus 3 is equal to 21, right? Which is, look at this, x plus x is 2x minus 3 equals 21. Look over here. 2x minus 3 equals 21. 2x minus 3 equals 21. Same thing. It's just two different methods. One is just using a one variable method. The other is using a two variable method, which means you need two equations. If you have two variables, you have to have two equations to solve it. Right? Remember that? Remember that? All right. Does that make sense? Fist to 5, you get it? Sort of? A little tricky, huh? 4, right? So you got to practice a little bit. Now, I would suggest you watch this video again, tonight when you're doing these problems. I think what I'm going to do is I'm going to stop. We'll do some more of these more complicated ones tomorrow as you start to get more used to them. But I'm curious, which method do you guys like better?
I like one variable.
Like the first variable.
All right, so let's do a show of hands. How many people like the first method, the one variable method? Okay, we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. How many people like the two variable method? That's interesting. Okay, so this is pretty easy. They're both really easy to me. So I think, but so let's focus on this method for now, okay? And we won't even worry about that. We've done other systems of equations with problems already. But I think I'm going to stop the lecture